All right, so the first example here is growth time. So how long will it take $10,000 to grow to $12,000 if it is invested at 9% compounded monthly? And so this is method one. They want us to do three different methods in the book. So this one is to use logarithms and a calculator. All right, so what do we need to do? Well, we're just going to use, well, they'll let me write here. It'll be use the A is equal to the P times 1 plus the R over M times M, or to the power MT. And so A is going to be 12,000. That's the future value. Current value is 10,000. And then that's times 1 plus R over M. Well, 9%, so that's 0.09. Monthly, that's going to give us a 12. Then we'll have 12. And how long it's going to take, that's going to be what we are looking for, T. Okay. So with that said, then what we need to do is we need to solve for T. So using logarithms, first thing that means is we're going to divide everything by 10,000. And so, we can divide this out, and that just gives us a 1.2 here is equal to, then we have a 1 plus 0.09 over 12, and that's to the 12t. And again, I think the best way to do this would be take the ln of both sides, because then we can bring that down. And so then we have the ln of 1.2 is equal to 12t ln of 1 plus 0.09 over 12. All right. And so now we can divide everything by 12 ln 1 plus 0.09 over 12. And we'll divide that side by that 2, 12 ln of 1 plus 0.09 over 12. And that should give us our t value. All right, so now let's see if we can remember all that to type that in. All right, so we have the ln is over here, 1.2 divided by, and so then we divided that by, we had on the right side, what was it? I have to go back again, I forgot already. 12 ln, okay, so we have 12, when you parentheses 12 ln of 1 plus 0.09 divided by 12 in parentheses, and that should give us our value. And it looks to be 2.0333. And so that's going to be our value. So let's go back over here. So that's going to be 2.033, and that's going to be in years. And so it's going to be 2 years. And so now we need to actually convert that other piece here. So let's subtract 2 and then take that times 12 to get the number of months. And so that's really kind of about a month, less than a month. And so we'll say 2 years and 1 month. So that would be the minimum it would have to be. You couldn't have 0 months, because then you wouldn't ever actually get to that value 12,000. So that's going to have to round up to the next month up. And so that'll be 2 years and 1 month. And so that's how we would do this using logarithms. And also, again, playing with the values here. You'd have to subtract the 2, multiply this by 12 to get how many parts of a month it is. It was 0.4. Can't have like less than that, so you have to go to the next month above, and so that was going to be a 1 month here. So 2 years and 1 month would be our value. All right. So method 2 says using a graphing calculator to graph both sides of the equation and find the point of intersection. All right, so we can do that as well. So let's go do that over here, go back to here. And what we have to do is we have to remember kind of what we had before. So let's do graphing both sides of the equation. So on the left side, we'll clear that. We had 12,000. And then on the other side, we had, now we can go back here. So we had the ln We don't need the ln's, no. We just needed the 10,000 times 1 plus 0.09 divided by 12. And then that was raised to the power, and that was going to be 12. And now we're going to use x instead of t because we have to do that. And so now we should get the two lines. Now, probably we come over here and it's not going to look very good. First off, what we need to do is we need to get rid of our stat plot. So we have to turn stat plot off. So you'll run into this when you're doing it too. You'll have stat plot on for one thing. Now we don't have any values. Now let's see if we can, I don't know if Zoom 9 will work on this or not. It has to be a Zoom plot. So what we have to do is get our right window. So our X's and Y's, so probably X's are going to be from 0 to, I don't know, let's go to 40. Shouldn't be much more than that. Our Y's are going to be, though, let's go from maybe 8,000 to maybe 14,000 by, let's see, 1,000 and see what that looks like. All right, so we have it. So now that's our point we need to look at. And so now what we need to do is do a second calc. We need to find 5, the intersection. And here we can just choose both lines and make a guess. And again, it gives us x is 2.0333823. And so that's where it's going to be at the 12,000. And so this way, we graphed the equation again. So we graphed on the left side the 12,000. On the right side, we had 10,000 times 1 plus 0.09 over 12 times 12x. We plotted those. We got 2.03338 as the x, and the y was 12,000. And this turned out to be 2 years and 1 month. Okay, so that's how you can use the value where the intersect is to help you solve these problems. Let's see. Now, method 3, use the equation solver feature to solve the equation. All right, so the nice thing about this is we have typed both sides of the equation in already. So we've got this part done. So on most calculators, in this case being, if you have the 84 plus, it's going to be how you do it. If you have an older version, we might have to talk in class or something about that. But here we're going to hit math, arrow up, we want numeric solver. And what we're going to do is we're basically going to set y1 equal to y2. So this is equation 1, this is equation 2. We're setting the two equations equal to each other. And so let's call this one, since we already have y1 here, let's call this one y2. And what we're doing is we're setting those equal. And now you have to hit graph because graph is underneath OK on the calculator if you actually do it. And sometimes you'll have something here like 5 or 1 or something like that. Since we already had solved that one, it had the number there. So if we hit graph, then it automatically tells us that's our answer. Now, if we had something else in here, say maybe a -5, that might not actually work. But in this case, it does because it has only that one intersection. So the key with using the numeric solver is sometimes you're going to get multiple points because depending on how your graph looks, it's going to do different things. So sometimes the choice you make here really has to be a best educated guess, because if I had said, -5,000, that really wouldn't make sense. But if I said, maybe a 5, that would make more sense in this case. And then it would get to, again, that 2 years and 1 month thing. So that's kind of how we use this. Again, what we do is set E1, we plug in Y1, which was equal to the 12,000. We'll say it's that on this one. It's not, we had E1, E2 backwards. And Y2 was going to be the 10,000 times 1 plus 0.09 over 12 and to the 12x. And then you use the numeric solver and solve it, and it does that. So plugging it into Y1 and Y2 really helps because you can see the graph of it, whatever it was, it had it appear at 12,000 and something like that. Plus you can use numeric solver to solve for the X automatically. You don't have to do any calculations. And so it's one of those useful things, that equation solver. I always plug it in here. Sometimes people just plug it directly into over here. If we do this again, they would type it in here. So what you could do is you could type 12,000. Here you could type the 10,000 and then the 1 plus 0.09 divided by 12. And then that's raised to the 12x. And then you're going to hit graph. And again, let's say we have 9, and it gives us the same answer. And so it shows us here what the actual values are instead of like y1, y2. So different ways to do it, all works the same as far as we get the right answer. So that's the kind of the key as far as what that does. And again, so we get, 2 years, 1 month. Okay. All right, so let's stop there and we'll come back with more.